All right, we're going to continue on with our unit on solving equations. We're going to talk about solving multi-step equations today. So I just have a few tips to kind of consider when we're solving multi-step equations. The biggest thing that I can stress, I think, is probably that we need to simplify both sides of the equation first. Before you start trying to solve for your variable, make sure both sides are simplified. And when we're doing this, we may have to use the distributive property. If the onion method has been useful for you and you liked that, we can definitely use the onion method once our equation is simplified. And then this last bit, if you have an equation with fractions and decimals, sometimes those are hard to kind of work out, so we can actually clear the fractions and decimals using multiplication. So we'll get to some of those examples here in the end. So let's jump right into some examples here. Number one, the first equation, let's look at 72 plus 4 minus 14d equals 36. Okay, so my first tip was simplify both sides of the equation. So if we look at our equation, you may notice that this left-hand side, this is not simplified. I can combine together this 72 and 4. So we want to go ahead and do that. So I get 76 and then minus 14d equals 36. And then from here, if you, like I said, if you like the onion method, we can go ahead and build our onion. So we'd circle the d, and then going in order of operations, I would circle the 14 and then the 76. So we see the outer layer of my onion is that 76. So the first thing we're going to do is subtract 76 from both sides. So I have negative 14d equals negative 40. And then to get rid of the negative 14, we're going to divide both sides by negative 14. Now 40 and 14, that's not going to go in evenly, but we can do some simplifying. First, I have a negative over a negative. That's going to give me a positive answer. And then they both also have a 2 in common. So if we divide out a 2, we should get a positive 20 over 7. Okay. Let's try another one of these. Number 2, let's try 6p minus 2 minus 3p equals 16. Okay, so same thing as before, we want to make sure both sides of the equation are simplified. If I look at this left-hand side, hopefully we notice that these p's, the 6p minus 3p, I can combine those together. When I combine them together, I get 3p. And then I still have the minus 2, and then I have the 16. Okay, so from here, if you wanted to build your onion, we'd do the p, and then the 3, and then the minus 2, which means the minus 2 has got to be the first thing to go. So if I add 2 to both sides, I'd have 3p equals 18, and divide both sides by 3, we should get p equals 6. So hopefully you're noticing it's pretty much the same thing we did yesterday, just maybe a couple extra steps in between. Let's try number 3. Looks like this. 17 equals p minus 3 minus 3p. So I want you to look at that for a second, see if there's any simplifying you think you can do. If I look at that left-hand side, nothing I can do to simplify 17. But that right-hand side, I can combine together the p and the minus 3p. So my equation turns into 17 equals, now it's p minus 3p, so it's actually going to be negative 2p. And then I have my minus 3. Okay, if we build our onion, it would look like this, the p, and then the 2, and then the minus 3. So to get rid of a minus 3, we do the opposite. We add 3 to both sides. So I should have 20 equals, it's still a negative 2p. And then to get rid of the negative 2, divide both sides by negative 2. 20 divided by negative 2 gives me negative 10. So we get negative 10 equals p. Okay, let's look at some that are going to be a little bit different. You're going to have to use some different ideas. Okay, number 4 looks like this. 64 equals 8 times r plus 2. Now, anytime I introduce these, most students have this same idea at first, and it's usually the right idea. Most students, the first thing we want to do is distribute, and you are going to be correct. We're going to use the distributive property. Just remember to be careful with the distributive property. Make sure you multiply everything inside of the parentheses by that 8. So this should be 64 equals 8r plus 16. Now sometimes I have to use the distributive property you may be able to simplify. In this case, I can't. So we're going to go ahead and solve this equation. So we would subtract 16 from both sides. 64 minus 16 should give me 48 equals 8r. And divide both sides by 8, and we should get 6. Okay, now one thing I want to kind of point out to you guys is that in the very beginning, so let's look at this equation again, but we're going to look at it a different way. So let's rewrite it. 64 equals 8 times r plus 2. Instead of distributing first, I want to see what happens if I build my onion. So if I circle the r and then think about the order of operations, the next thing I would need to do is the parentheses, so that plus 2. And then after that, then I would multiply by 8. So if we do the onion method, we see that that 8 is actually going to be that outer layer that I need to get rid of. Well, in order to get rid of the 8, remember we're using inverse operations. Well, this is 8 times r plus 2. So to get rid of the 8, we can actually divide both sides by 8. So notice I'm not going to actually end up doing any distributing at all, because now I have 8 equals r plus 2, and then I can finish by just subtracting 2 from both sides. Notice I got the exact same answer. Now, it's not always convenient to divide out this number, but sometimes it really is. So let's look at one and let's decide if we want to distribute or divide. So let's look at number 5. It says 7 times the quantity f minus 1 equals 45. Now I want you to notice that if I built the onion, it would be the f and then the minus 1 and then the 7. So it looks like the 7 would be the first thing to go. Now what I want you to notice is that if I were to divide both sides by 7, 45 over 7, that is not going to go in evenly. So that's not looking like something I want to do. So if it's not something that goes in evenly, I would probably recommend go ahead and distribute. So I get 7f minus 7 equals 45. And then we can go ahead and add 7 to both sides. So we get 7f equals 52. Divide both sides by 7, and we can just leave our answer as an improper fraction. You would get the same answer if you would have divided out the 7, but it would have been a lot more work. Okay, let's look at another one here. What about, okay, number 6. Got 2/3 times the quantity x minus 2 equals 5. Now, if I look at this one, if I were to distribute that 2/3, I want you to notice that I would get 2/3 x minus a fraction. And then what I'm going to end up having to do is I'm going to have to add that fraction to both sides. I'm going to have to find a common denominator. It's going to be a lot of work. So in this one, if we were to go through and instead build our onion, I want you to notice that that 2/3, that's on the outer layer of the onion. So that's the first thing that we would need to get rid of. Now, if we think back to what we did on Monday, we talked about how to get rid of a fractional coefficient. And if you remember, in order to get rid of a fractional coefficient, we did what was called multiplying by the reciprocal. So in this case, instead of distributing the 2/3, I can get rid of the 2/3 by multiplying by 3/2. So notice those cancel out, and I get x minus 2 equals. And on the right-hand side, I am going to get a fraction, but in my opinion, I think it's still going to end up being a little bit easier. So ignore the fraction. To get rid of the 2, we're going to add 2 to both sides. Okay, in order to add these together, we are going to have to find a common denominator, which we hopefully know is going to be 2. So I have 15/2 plus 4/2, right? 2 over 1. Think, how do you get from 1 to 2? Multiply by 2, so we're going to do the same thing to the numerator. So then, when I add these to both sides, add the numerator. 15 plus 4 gives me 19. Keep the denominator the same, we should get our 2. So we should have an answer of 19 over 2. So it may have not been incredibly easier than distributing the 2/3, but in my opinion, it was a little bit easier. Okay, now let's look at some that are a little different. Okay, and this is going to come up with that last tip that we talked about. So this one says a over 7 plus 5 over 7 equals 2 over 7. Now for this one, we could deal with the fractions and solve as normal. Or that last tip said, instead of dealing with the fractions, I can clear the fractions using multiplication. Now how this is going to work is I'm going to multiply both sides of my fraction times something that's going to get rid of the fractions. So if I think about a over 7, 5 over 7, and 2 over 7, which keep in mind all of these are a divided by 7, 5 divided by 7, 2 divided by 7, you may notice that if I were to multiply all of these fractions by 7, I wouldn't have any fractions left. So here's what we're going to do. We're going to multiply both sides of the fraction by 7, okay? And then what happens is you actually distribute. So I have 7 times a over 7 plus 7 times 5 over 7 equals 7 times 2 over 7. So notice, all I did, multiplied both sides of the equation by 7, multiplication property of equality. But then if I look here, see how the 7's cancel out and I just have a? See how the 7's cancel out and I just have 5? See how the 7's cancel out and I just have 2? I have no more fractions and this equation just got a whole lot easier. I can subtract 5 from both sides. We get a equals -3. Now in this problem, it just so happened that what I multiplied by was my denominator. That's not going to be the point every single time, but what it actually is going to be is it's going to actually be my least common denominator of all my fractions. So that's the number we're going to be looking for, is the least common denominator. So let's look at number 8. That's going to be kind of similar to that. Okay, number 8 says 11z over 16 plus 7z over 8 equals 5 over 16. Notice in this one, my denominators are not all the same. So what we're looking for is the least common denominator, okay, or the least common multiple. So if I look at 16, 8, and 16, this one's pretty easy. The least common multiple between all those numbers is going to be 16. So this is the number that I'm going to multiply both sides of my equation by. We're going to multiply everything by 16. And remember, when we do this, what we're really doing is distributing that 16. So I have 16 times 11z over 16 plus 16 times 7z over 8 equals 16 times 5 over 16. And then when I go back and cancel out all my denominators, I should end up with no fractions. So that first term, the 16's cancel out and I have 11z. The second fraction, the 8 cancels out. The 16 doesn't completely cancels out. I should be left with 2. 16 divided by 8 gives me 2. And then what I have to do is take 2 times 7z, which gives me 14z. And then on the right-hand side, the 16s are just going to completely cancel out, and I'm left with 5. Notice, in my fraction, or in my equation, no more fractions. This just got a lot easier. I can combine my z's together and get 25z. It's 11z plus 14z. Divide both sides by 25. Okay, and so 5 over 25, it's not going to go in evenly, but I can divide out of 5 from both of those, and we should get 1/5. Okay, so for the fractions, we're looking for the least common denominator. Multiply both sides of the equation by the least common denominator. It gets rid of your fractions, makes it a whole lot easier. We can apply a similar concept to an equation that has decimals. So let's look at a couple of these. Okay, number 9 says 1.06 g minus 3 equals 0.71. Now, I'm not going to multiply by least common denominator or anything like that. What we're going to multiply by is a power of 10, because we know, hopefully, that multiplying by 10 or 100 or 1,000, all it does is it keeps the number the same. It just moves the decimal place that many places to the right. So if I look at my equation, I have 2 decimals here, and I have 2 decimals here. So if I were to multiply by 100, it should get rid of my decimals. So once again, I have to multiply both sides of my equation by 100. And then even more, on this left-hand side, I have to distribute that 100. And even though the 3 doesn't have the decimal, in order to keep the equation equivalent on both sides, it still has to be multiplied by 100. So remember, multiplying by 100, since it has two zeros, moves the decimal 2 places to the right, so that's going to turn into 106G. 3 times 100 is 300, and then 0.71 times 100, that's just going to turn into 71. And now notice this equation looks a lot simpler now. So I can add 300 to both sides. So I have 106G equals 371. Divide both sides by 106. And if you punch that in your calculator, we should end up with 3.5. So it makes the equation a lot easier than dealing with the decimals. Let's try one more of those. Okay, number 10. Okay, let's do 25.24 equals 5G plus 3.89. So with decimals, what you have to decide first is what power of 10 you're going to multiply by. So you're kind of looking at how many decimals do I need to get rid of? Well, we notice I have 2 decimals in my first number and 2 decimals in my next number. So it looks like I'm going to have to multiply by 100 again to get rid of those 2 decimals. So on the left-hand side, 100 times 25.24, that's just going to turn into 2,524. On the right-hand side, remember, even though that 5G doesn't have a decimal, you still have to multiply it by 100 to keep the equation equivalent. So that's going to turn into 500G, and then 3.89 times 100 is going to be 389. And then we can finish solving, subtract 389 from both sides, and we should have 2,135 equals 500G. Divide both sides by 500. And we should get G equals, if you punch that in your calculator, should get 4.27.